So to keep things on track here, we'll go ahead and get started. My name is Ramsdale. Thanks for coming out today. This packed house is fantastic. So I'm going to give two sessions today that are on Google Web Toolkit. The first one's going to be more of a 101 session to get everybody on the same page about what you can do with Google Web Toolkit and how you can build rich web apps. So from a show of hands, how many people have actually used Google Web Toolkit to build an application before? Great, I think there's a lot. There's blinding lights in front of me, so I'll assume that's happening. So today we're going to go through what Google Web Toolkit is, give you an overview of that, and we're going to talk about tools for developers, and then optimizations for users, and then we'll give you an intro to what best practices in Web 2.1. So from a 25,000 foot view, what is Google Web Toolkit? Well, it's a development toolkit, it's not a framework. Nothing against frameworks, but the notion is that we are a set of tools that you can pick and choose to make web applications. You have a compiler, we have code generators, we have Eclipse support, we have plugins for IDEs. You can pick and choose either one, and you don't have to buy into all of them, unlike frameworks like Spring or other ones that are exposed maybe by JBoss. So the one thing you do have to buy into is that you're coding in Java. You're writing front-end code, and when I say front-end throughout this presentation, I'm talking about code that runs in the browser. So you're writing front-end code in Java, but it runs as JavaScript. We have, again, a compiler and a set of code generators that take that Java code and turn it into HTML5 and CSS and JavaScript. Another thing is it's one code base in each browser. So if you're running a consumer-based application, you typically have users that are using both IE, Firefox, Safari, Chrome, some Opera users, depending on where you're at. What we try to do is give you the ability to write one single application with no tweaks, and it'll run it in your browser. Fourth, we make Ajax a piece of cake. Not that it's rocket science to begin with, but there's a lot of boilerplate code that goes into doing Ajax. There's a lot of serialization, deserialization code, some stuff that I talked about in the keynote today. And with GDD-BR, we try to make that a piece of cake. We try to make it faster because we have a holistic view of your application. That means we know what types you're sending over the wire, we know what types you're expecting to get back, we know how to serialize them optimally, and so we can reduce the payload and ultimately make your application even faster. And then it's finally, GDD is used within many products, AdWords, Tookit, which is local to you guys, and hundreds of internal applications as well. So the GDD Google Web Toolkit started out as just an SDK, but it's grown over the years. Now we have the GDD family, as I like to call it. There's the GDD SDK, there's the Google plugin for Eclipse, there's SpeedTracer, and that was a recent addition to the family, which is the Google Web Toolkit Designer. It was part of a company called Instantiations that we acquired about several months ago. We're now in the process of bringing their products into the IDE as well, making one unified Google plugin for Eclipse. Now, the way we view these tools working together is that you design and develop using the Google Web Toolkit SDK and the Google Web Toolkit Designer. You're going to debug using our Google plugin for Eclipse, right, within the IDE. And then you're going to optimize with SpeedTracer. Now, for some of you that are not familiar with SpeedTracer, if you ever used Firefox and Firebug inside of Firefox, it gives you an idea of like how your JavaScript's operating. You can do some debugging. It gives you some introspective look into your application. Well, SpeedTracer takes that one step further. And it actually has hooks inside of WebKit so that it can see when you're doing things like painting, layouts, garbage collection, things like that, to identify where your app might be sluggish in the browser. So when we typically think about who we're targeting, right, we have two focuses. We have the focus on the user. We have focus on our users. So that's the developers, everybody in this room. And for those users, we look to leverage existing IDEs and tools. Right? Again, everything that's available in Eclipse that was normally available to server-side programmers or mobile programmers, we should make that available to web app programmers as well. We want to minimize the refresh time between code changes so that you're not actually going and making a change, having to recompile and redeploy, and it takes many minutes to do that. It should be instantaneous. And then wherever we can, we want to automate where possible. Again, we have tools that are operating on your Java code. We know things and we can do things based on that that minimize the amount of code that you have to write. Let you focus on the next killer feature. But then we focus on your users, which are the end users, your customers. And there we want to minimize startup time, and we want to make it a comfortable experience, right? We want to get them off of desktop applications and get them into the web, into the browser. That's why we have to make it as fast as possible. It needs to feel like a desktop application. And then finally, we want to make it a comfortable experience, meaning that we want to let them use whatever browser they're comfortable with, right? Whether it's Safari, again, Firefox, IE, or Chrome. So we have different goals when we look at this different users. You as developers focus on writing the next killer feature, making it look good, and doing some code refactoring. Say you picked up a piece of code from your colleague who's left the company, you think it's terrible, you want to go refactor it, make it better. So that's what your goals are right there. Goals for your customers are a little different. They just want to make it fast, and oh, by the way, don't charge my credit card twice if it's a backlog. How many times have you been using a banking application and you're like, if I go back, are they going to charge me twice? So they would appear to be different and somewhat competing goals, right? That's not the case. So with Google Web Toolkit, what we've done is we've made it possible for you to focus on what you want to do as a developer, right? Write a great app, killer features that you're proud of. And then we'll take care of making it fast and doing things like handling history support for you, right? Let you focus on the features. So some backstory on Google Web Toolkit. No plugins required. Now you'll see me talk about a developer plugin that we use for us developers. But for your customers, it's just HTML, CSS, and JavaScript. So you don't need any Flash plugin, you don't need any Silverlight plugin to run the applications. It's nothing against those plugins. I think they're great actually. We just don't want to run into this, right? So some plugins not available for, let's say, your mobile phone, and you can't run an application on it. So look, stick to standards, right? Eric talked about cloud portability. Well, it's not just cloud portability, it's the ability to run your application anywhere on any device and not have to worry about two companies working out some silly agreement. So quirkiness. If you just focus on IE, this is not going to be of great importance. But if you have to focus on any other browser other than IE, it gets to be important. Because what we've done is that each browser handles certain pieces of JavaScript code and CSS just a little differently. So here's one example. If I want to take and I have a div, like just a spot where I can put in some HTML, there's a couple ways I can do it. I can say set inner text, I can set text content equal to some HTML, or I can say inner text equals some HTML, right? And each way is a little bit different. Some browsers support one, some browsers don't support the other. And if you had to write this by hand, you'd have to know which way to optimize. Because, for example, on Firefox, it's a little bit faster just to say inner text equals, right? And on IE, it's significantly faster to say inner text equals. So what we do is we take those and we found the most optimal way, and we expose an API that's just normal for you. So you just simply say set text or set HTML, and then we'll take care of doing the right thing for you under the hood. And you know, you might not think that in terms of milliseconds this is very big, but if you look at it, the percentages are pretty good. You get a 14% savings on Firefox, Web gives you 29% savings, so on and so forth. And it doesn't just end here. You definitely should check out this guy's blog, because it's filled with pages and pages and pages and pages of weird things you'll run into as you start to build out your application. Granted, you're not going to run into them in the first few days, but look, we're in it for the long haul, right? We're going to write an application that's going to take 3 months, it's going to take a year, it's going to take 2 years, and it's going to grow, and eventually we're going to get to some weird state where like, oh, it just doesn't quite work right on IE6. So we take care of that for you. Another thing, and this is why we love tools so much, right? This is JavaScript right here. And I urge you to say, it's pretty trivial, but can you find the bug with this example? Well, if you can, go ahead. Right, yeah, exactly. So it's pretty simple, right? But it doesn't look like it. So if you actually ran this, the way you find the bug, unless you're just staring at it on a big screen, you'd run your app, and you probably get 3 screens into it, and you get some weird JavaScript null exception, have no idea what's going on, have to trace it back in your code, you've wasted about 2 hours, totally ridiculous. But if you actually use Google Web Toolkit and our plugin, what you get is nice little red squigglies, right? And they sound so silly, just red squigglies, but you take them for granted almost, because what they do is they tell you immediately that you've done something wrong with your application, fix it now, don't worry about going 3 screens down into it and coming back up. So demo time. So to see this in action, let's create a new web app, and then we're going to actually run it in the browser and hit a breakpoint within the IDE. Let's close online. So here, again, this is a Spring Source Tool Suite, what I was showing this morning. And if we go to New, and hit Other, create a new web application project. And we'll use Google Toolkit. I'm not going to use App Engine. Call it Demo. You know what? I actually realized that I don't have a valid SDK installed. So here's what we're going to do. We're going to expand on the demo that we did this morning. So this was the application that I created with Spring Boot this morning. And while I did a simple refresh demo, all we have to do is come in here and say debug this web application. And it's going to start up the debugger. So I started the debugger. I'm not going to worry about it here. What I want to try to find is my entry point for my application. So we come in here to step 1. So there we go. Okay. Sorry about that. So now, same thing as today, as this morning, with Firefox. Give it just a second as it goes. So it's doing quite a bit here. It's actually compiling the Java code into some JavaScript, shipping it over the wire. We're going to get into how this actually works in just a second. All right. So. Laptop? I know you can. All right. So now, not much to show here, but what I've done is I've actually launched development mode from within the IDE. So I've told the Google plugin for Eclipse, go ahead and launch this, launch it in my browser, and I set a breakpoint in my Java code. And that's what I hit right now. So I'm actually sitting in the IDE. I have a full stack trace, I have a full call stack as well. I can see what's going on. And as well, I can walk into it. So if I go to run, let's do step into. I'm actually stepping into my code now. And I can, as I traverse this, I can actually debug both the client and the server side as well. So then finally we can just hit run. Sure enough, my application should be running. Oh, it's warning me because I took too long to actually complete the script, but if I continue, I should be good to go. So there we go. So same demo as this morning, only instead I've actually debugged it instead of done a run as, and I've got a breakpoint that's landing inside of my IDE. Let's see how that works. So before we jump into that, we typically have a joke back in the office that we're really just a Java to JavaScript compiler, right? That's all we do. And in fact, that is a large portion of what we do. We take Java and turn it into JavaScript. In fact, at some point, we actually said, this looks a lot like assembly language because this is the compiler output from the GDD-C, or from the GDD compiler. And what it does is it takes your Java, turns it into JavaScript, obfuscates it, and then minimizes it. So you have a small JavaScript download at the end of the day. But you can always change that. And so let's say I actually want to see what the compiler's outputting. I can change it to pretty print. And now I have something that actually looks like JavaScript. So if you've ever done any normal just HTML, CSS, and JavaScript programming, this should look pretty familiar, right? You have an init function, you have some other things going on, some exception handlers. So now, let's go back to the demo and take a deeper dive to actually how that happened. So how did I actually get to where I was running in the browser with debugging in the IDE? So tools for developers, right? So when I hit go inside of Eclipse, in this case it was Spring Source Tool Suite, which again is just a branded version of Eclipse. When I hit go and hit debug as, what happened was the Google plugin, our Google plugin, started up a code server, which is just a server listening on a TCP port, and it started up a Jetty server. Jetty's like Tomcat, it's just an embeddable web server for hosting your application. And then when I launched Firefox, there's a plugin in Firefox that actually that is making a TCP connection back to the code server that's running into an Eclipse, and they're passing JavaScript objects back and forth. So that as I'm stepping through my code, and I'm translating in the Java into JavaScript, I'm shipping those over the wire back to the browser, and the browser taking it and injecting it into the page. So I really do get step by step by step when I'm debugging. So if we look at it from Eclipse to deployment, how do we actually get to the point where we have an application that we want to deploy? So we start with your code. This is just code that you have in Eclipse. And then we want to run it through a series of generators. And this is where a lot of the power of a Google Web Toolkit comes from, right? So we'll take a look at two use cases. And when we look at generators, what we're really talking about here is, again, the power behind your GUID app. And then one of the other goals is that we want to automate away a lot of the boilerplate code. And then the foundation for how we can split your app to serve up the right version on Eclipse, the right version on Firefox, the right version on Safari, and the right version on Chrome. So let's take a look at two use cases for why code generation is so good. One, we take a look at typical RPCs, just remote procedure calls, right? So the way this happens in a typical application, this is a typical AJAX call, is you have a client, right? And it takes an object, it serializes it, turns it into an XHR, which is an AJAX request. Then it hits the server deserializes it, does something with it, gets a response, serializes that, sends it back over the wire, and you deserialize it, and your application is running. That's a lot of code you don't need to write, right? And not to mention, if you start bumping versions, it's a real pain. So what we do is we come along and we say, well, since we know we've seen all your code, we know what you're trying to do, we're going to put two proxies in between. So the client ends up calling a proxy which just says, take this object and send it to the server, right? I don't want to care about serialization, blah, 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 blah. You just do it. So the web proxy says, great, I know how to serialize that. I have code to do that. So it turns it into a format that it can send over the wire. And again, that's just using XHRs. Then when it hits the server, it actually doesn't hit your server-side code right away. It hits a web proxy, again, that's running, it does a deserialization, hands it to your application, and so your server-side code, what it's dealing with is objects. It doesn't have some JSON payload that it has to deserialize and get back the objects, it just gets the objects. And then the same is true for the reverse path. So what you end up doing is you write code that looks like this. So the top portion is your client code. And what you're doing is now I'm putting together a trivia example where you would do a suggestion service. So it's like when you would type in Google and you'd say, I want to do a search, and you get back some search results. You'd say, okay, I'm going to define a suggest service, and I'm going to expose a method that's called getSuggestions, and it's going to return back an array of strings when I pass it a string. So if I type in app, it'll return me back Apple and some subsequent matches as well. Then when I actually want to, and that's how I define my service, that's all I have to write on the client side. Now when I actually click a button and actually want to do something and call this, it's as simple as the code below. So I have an on-click method, say I click a button, and all I have to do is say suggestService.getSuggestions, get the text from my search box, and then provide some callback mechanism. That's really all the code. The key here is that you're not dealing with some arbitrary strings. You're dealing with objects that you can pass back and forth, strongly typed objects that you can, not only can we compile and optimize for you, but you get tooling around as well. So you get code completion, refactoring, and so on and so forth. And at the end of the day, it's really simplistic code that's easy to maintain and easy to scale. So let's take a look at use case number 2, which is creating UIs. So typically, if you've used Google Web Toolkit prior to our 2.0 release, what you found that you were creating UIs by specifying a whole bunch of Java, lines and lines and lines and lines of Java. So what we did was we decided that for our 2.0 release, we're going to utilize some common dev practices, and that's we're going to make UIs declarative. Make them feel like you would normally write them when you're doing a web application, which is to use XML, right? Because when you're creating a web application, you're just creating HTML, right? That's typically what you're used to doing. So we said, okay, we'll do it in XML. We said, by the way, when we do this, we can again minimize some of the boilerplate code. You're going to hear this time and time again when we talk about Google Web Toolkit. And then we want to remove some other frustrations along the way. One of them being, if you've ever done, again, a typical web app and you use a lot of CSS, you'll find that you have one big, huge monolithic CSS file with a lot of strange names because you don't want to have namespace collisions. So there's some things that we can do there to break that out so that when you define this widget that has sub-widgets and it has this style and it's in this one file, we can make sure that that CSS is specific to only that widget. So what you end up doing is you write code that looks like this. So this is self-contained. It is a widget on a page. And all I've done is at the very top, where it says UI style, I've specified some style. I want some margin, I want some padding around this widget. And then I drop down to below, where I think this is really powerful. I start to lay out my UI, again in a declarative form using XML. And if you squint just a little bit, this looks like standard HTML, only we've used some widgets here. So you notice things like horizontal panel, that's specific to Google Web Toolkit applications. Then we define 2 buttons. So what you end up with is a horizontal panel with 2 buttons in it with some padding around it, that's it. Now you can see how you can start to expand on this. But the beauty is this is self-contained. So if I have styles inside of here, right, they're specific to only that widget. They will not affect anything else on that page. And then what I can do is, by using the UI field mechanisms, you'll see that UI field add button, UI field delete button, I can then go annotate my Java code with those same field names and implement click handlers for them. And the generators come along and they will link up my declarative UI, the XML you see right here, and the Java code where I've annotated with these UI fields. And when I talk a lot, if you're a current Google Web Toolkit user, I'm going to have a few tips and tricks as we move through here. But if you're ever interested in what we're generating, the code that we're generating, the code that I'm talking about, you can simply pass a -gen flag to the compiler, and you'll see all this firsthand. In fact, we'll talk about a couple other flags you can pass to the compiler to optimize your application in just a second. So good, so we've talked about generators, right? So moving along the chain to getting to production, we're going to talk about translators. But it gets pretty simpler after generators, because translators, all they are, that's where the Java to JavaScript compiler comes in. We've taken your Java code, we've taken the code that we're generating, right? Now we have the entire app. It's all Java source. And what we do then is we take our compiler and we run our compiler pass on it. That compiles it to JavaScript and then optimizes it along the way and obfuscates it and compresses it so that it's minimal. That's it. So then we get to linkers. Now, if anybody's ever done compiler design or worked on compilers before, you'll notice a pattern. This is typically what compilers do as well, right? If you took a normal C++ compiler, you would see that instead of generators, they have macro expansion. And then translators, that's actually when they're translating it into assembly code. And then linkers to pull it all together to give you the exe that you're looking for. So we're doing stuff that's similar. And the exe that it produces is typically tied to a platform, right? It's the binary that you would hand out if you're building an application. Same thing goes for linkers here, right? The linkers are the entry points for your GWT application, for your Google Web Toolkit application. Now, that could be I want to load from my site, or I want to do a mashup where I load from your site onto my site. So there's some cross-scripting going on. Or I actually want to create a mobile application, in which case I'll have completely separate entry points, so that I can serve up just some slightly tweaked HTML, but still the same JavaScript on the back end that I'm using, and generating from your Java code. So again, when I talk about entry points, this is what I'm talking about. There's permutations. If you go off and you use Google Web Toolkit, right, you'll end up generating something that looks like this. Now, it looks a little bit cryptic, and that's fine, but what you end up with here, each of these HTML pages are for a specific browser. They're for Internet Explorer, or they're for IE. They're for IE, or they're for Chrome, or they're for Safari. And they're also per language as well. So you can serve up a specific application for Internet Explorer 6, for the English version, or for whatever language you're actually serving up. So you've heard me talk about optimizing away boilerplate code, right? And I'm really focused on developer efficiency. That was one of the messages we were talking about in the keynote. So here I kind of go through some of the developer time sucks, as I call them. And what we see typically is that you want to go write some code, you run it, you push a few pixels around, right? Have you ever gotten to the stage where you're just tweaking little things here and there? So you just push a few pixels around, just make it look just right. And then you have to compile, and then you go off, and while it's compiling, you read some XKCD, you read some blogs, some Twitter traffic. You might debate with your colleague about what color to paint the bike shed. Then you revel in your accomplishments, because finally the compilation's done and you deployed it. And then you rinse, wash, and repeat. So you actually spend 50% of your day writing code, the other 50% of your day doing nothing and being unproductive. Well, you're having fun, but you're not necessarily being productive. So, we talk about, to look into that and what's going on, right? So if you're having to go through that cycle, well, you're going through that cycle for a reason, because you have trade-offs, right? You're not writing code because the compiler is running. When the compiler is running, it's optimizing your code. It's making it small. It's giving you this output. So you get speed, your end user gets speed, in trade-off for your productivity. So we think. You also get user experience, right? So while the compiler is running and it's doing all of its things and it's generating all those permutations, it's having to crunch through your Java code and actually spit out a version of IE6 that runs in English, a version of IE6 that runs in Japanese, and the same for all the other browsers. That takes a while. So again, trading off developer productivity for user experience, or so we think. So there's a couple ways you can accomplish this. So if you're having to go through the compiler phase, right, and you have the developer time stuff going on, what you can do is you can specify things. You can get a little tricky and specify things like, I just want to compile for Firefox running in English, because that's what I'm developing on, right? I'm in the development phase. I'm not in the production phase. I'm not going through the QA cycle. I'm just writing code and developing. That's one way you can do it. You can also speed it up by simply telling the compiler, hey, compiler, no more optimizations. I don't care. I'm just writing code, I'm just developing. It doesn't need to be super fast because I'm not pushing it into production yet. So you compile faster, you deploy it, you test your changes. And that kind of works too. But why worry about compiling at all? Like, why bother with this? The real way we should be developing code is simply like this. We write some code, we refresh the browser, just like I showed you. Does it work? No. Let's develop some more, let's refresh. Does it work? Keep that cycle going, and that's quick. Those are quick refreshes. So you're making changes and you're seeing instantaneous feedback. And finally, when you're done, then compile and then deploy. Hopefully the Google App Engine, but wherever you want to deploy. So what we do is, this is the software development lifecycle we want to see for web applications, for web app developers. It's what everybody else in the industry has. We should have it too. So great, we're happy, right? So as developers, we're happy now. We have, I think we are, I hope we are. We have tools that make us efficient. We've got strongly typed languages, that's good. We've got IDEs, that's fantastic. But what about our users? What about your customers, right? Are they happy? Are they getting exactly what they want? I mean, after all, the quick compiler is coming along and making you have really tight, small JavaScript. But you can go a step further. So let's talk about optimizations for users. So there's two ways you can do this. You can bundle resources, and you can split your code. Now, if you've ever done gaming before, written games, you do a thing called spriting, which is where you take a whole bunch of images, and you put them into one, and then you just do offsets to get to those. You can do the similar thing in Google Web Toolkit. So let's take a simple example. I want to associate icons with my contacts. Right? So when I do that, I have a contacts application. At some point in time in that application, I'm going to click a button. I'm going to get a dialog that looks like this, right? And I'm going to pick an icon to put with my users. Pretty simple. So, and I'm going to hand over a few of the details, so bear with me. But you can do this one way. You could go fetch all those 20 images. There's 20 images there. You can fetch those one at a time. Give me image 1, give me image 2, give me image 3. And that would work. So I'd fetch the image, and then you'd actually set the height and the width, and then I would add it to the images panel. It works perfectly fine. By the way, that is quick code right there. So this is what you'd see if you did that. Now this is Firebug running in Firefox, right? So what you see is initial download. So I'm going to go fetch my application. I'm going to pull it down, right? So I fetch my contacts.html, which is a really small file. And that tells me, okay, it looks like you're running on Firefox with the versions, with the language set to English. So go fetch this other JavaScript. That's the second fetch you see. That's 61K. Then later on in my application, you see a whole bunch of fetches to get the images, right? Those are all those 20 images. The problem is that when you do that, it's inefficient because you're actually experiencing all the HTTP overhead associated with getting an image. Now you don't think that's a lot, and it's not when there's 20 images. But imagine if you were getting 2,000 images. Or imagine you were scaling to the size of Bing search or Google search or Yahoo search. You need to be instantaneous. So you don't want to deal with that overhead. So there's ways to do that. There's one specific way to do that. What we can do is we can take advantage again of the code generation inside of Google Web Toolkit. And all we have to do is we say we're going to define an interface, right? The implementation of this interface is going to be generated by Google Web Toolkit. But what we do is we say, okay, I'm going to define an interface with a bunch of methods, and I'm going to annotate them with the path to my actual file, right? So what I have then is I have this interface, this nice interface, and I can say resources dot image 0. and it'll give me back an image resource, an actual Google Web Toolkit class that I can use to display that image. Now how I got that doesn't matter, because what we're doing is we're taking all those images, compressing them down into one file, and then overlaying this interface on top of it so you can actually call and get that image resource. When you do that, you end up with a call stack that looks like this. So again, we get the context.html, that doesn't change, it's 2K, very small. Then we go fetch our JavaScript. And we're like, that's a little bit bigger. I'll come back to that in a second. Then we move through our application, and suddenly when I pop up that image dialog again, you don't see the 20 fetches. So this is great. I've reduced all the HTTP overhead in my application. I've gotten rid of it. But the problem is, if you look at this really closely, the problem is that. So now all those fetches, right? I've taken all that data that I have to get, those 20 images, and I have to go fetch it when I initially get my application. So that's great, no more HTTP overhead, but that means my users have to experience that lag the first time they run my application. That kind of sucks. We don't want that to happen. Imagine if that, again, that was 2,000 images. You'd have to pull down 1, 2, 10 megs of JavaScript when you initially run your application. Imagine that doing that on a mobile phone. Unacceptable, right? So there's another way to fix that. So we introduced code splitting. Code splitting is just that, the idea that you're splitting your code. You're only going to fetch what you need. And if you've ever done optimizations in any application you've written, we call that kind of lazy fetching, lazy initialization. Go fetch all of my contacts when I ask for them. Do paging offsets. Well, this is the same thing here, only we're talking about JavaScript, right? So if at the end of the day, my entire application is 2 megs of JavaScript, but I only need the first 20K to show the first screen of my application, then why should I be able to do that? Well, that's what we have here. So now imagine if when I clicked on that button, right, when I clicked on the button to show that image's dialog, if I surrounded it with something that's specific to Google Web Toolkit, right, which is this GDD-BR that kind of wraps what's going to happen when I actually call the button. What the compiler does is it comes and looks for those split points as it works through the application. Again, the fact that we can have a holistic view of your application allows us to do these kind of tricks. And it says, you know what? The developer has said that he doesn't want to have this, he wants to split this off, right? And as long as it doesn't have any ties back into other portions of your application, it can be completely separated. The compiler will create a whole bunch of JavaScript files. And then when your application's running, it knows that like when it gets to a point, oh, I don't have that JavaScript, so I have to make a call out, and again, it's just an RPC call, an XHR, to fetch that JavaScript and bring it into your application, and you're running. The nice thing is that the call stack then looks like this. Exactly the way we want it. You get your initial HTML, doesn't change again, that's 2K. Then when you go and fetch your JavaScript, instead of being 160K like previously, it's back down to 39K, which is very reasonable. Again, trivial example, imagine this with 200,000 images or 2,000 images. And then finally, when I get later on in my application and I make a call to display the images, look what we have. We actually do the fetch to get the images, but we do it in a way that we minimize the HTTP overhead. So we have the best of both worlds. Quick startup time when I hit the application, so it feels like a desktop application, but then hyper-optimized throughout my application to only pull when I need to. And by the way, once you pull down the images, they're cached, so you don't have to do it again. So this way we get the best of both worlds. And so finally, to recap, we've talked about Google Web Toolkit, Java for front-end development, right? Tools to target large-scale applications, which means that you have now a language that works in IDEs and all these tools. Beyond the IDE, imagine all the plugins that are there for Eclipse and IntelliJ, right? They all work with Google Web Toolkit. So that in turn makes you efficient developers. And then, given the fact that you're efficient developers, you can go write killer features, and you can also start incorporating these best practices, tweaking for that last 10% because you're not worried about all that boilerplate code. So see, this is why I keep saying no more boilerplate code, no more of that just scaffolding applications you have to write. Let some tool do it for you. You can focus on killer features and making your end users happy. That's it. Thank you.